In the first video, we went over what radians are, where they come from, the fact that pi is equal to 180 degrees as a conversion factor, and then as well as outlining some of the common angles around a unit circle in both degrees and radians. Now we're going to get into some of the nuts and bolts, just how to convert one from degrees to radians, and then also what it looks like when you get onto a rotational grid. All right, I'm going to go ahead and take away this unit circle. And we are going to now focus on converting. So say I have an angle of 325 degrees. And I want to convert that into radians. By the way, all of these problems that I'm taking, I'm going to be deriving from the worksheet that is in Teams under Files. This is the angles and angle measurement worksheet. So if it's in degrees and I want to go into radians, I need to multiply it. Anytime you need to convert from one type of unit into another, you're going to need to multiply by an equivalent ratio. And so in this case, our ratio is either 180 degrees compared to pi, because pi is 180 degrees, or the other way around, pi over 180. And when you're deciding which one to use, you look at the denominator. The denominator needs to match the one you're in, and the numerator needs to match the one you're going to. So since we are in degrees, the denominator needs to be in degrees, and we want to go into radians. The numerator needs to be in radians. And when I do that, you'll see, oh, those degree units cancel. And I've got this great 325 pi over 180. Oh yeah. When we write these answers, we're going to use pi as just a part of that answer. We're not going to round it in decimal form, but because of that, we're going to have to simplify that fraction. And so this will be a challenge for some of us, but I'm going to kind of just do this one a little bit more step by step. I notice that they both end in 5 and 0, so I'm going to go ahead and divide those numbers by 5. And when I divide 325 by 5, I get 65. Let me just double check that real quick in my head. Yep. And then when I divide 180 by 5, I get 36. Okay. And there's still a pi up there. And since 65 is 5 times 13, and 5 and 13 don't go into 36, that's as simplified as it gets. And yes, that's where we need to end. Please don't give a decimal approximation. We are writing exact answers, exact angles in radians. All right. Okay, well, what about going the other direction? So what if I had an angle of negative 4 pi over 3? That's in radians. You see no degree symbol? It's in radians. Any number without a degree symbol, if it's an angle, it is in radians. All right, in this case, I want to get out of radians, so I'm going to multiply not by the one with 180 degrees at the bottom, but the one with pi at the bottom. So I'll multiply by pi's on the bottom here. The thing I'm in radians, and the thing I want to, go to here. Let me undo what I just did there, honestly. The thing I want to go to is degrees, so it's 180 degrees. And you'll notice, oh, that pi and that pi will cancel. And so I have negative 4/3 times 180. And when I do that math, I will get negative 240 degrees. Okay, so there you go. That's how to convert from degrees into radians and from radians into degrees. Okay. Now, what does that look like? What does it actually look like to have a certain angle when we talk about it on a grid? Because this is where we're in some math where we're talking about rotations. We need to know what a rotation looks like on a traditional XY grid. And so here's how angles are measured in an XY grid. You're going to rotate, and where you start from is the positive x-axis. So the positive x-axis is our starting point. We start rotating from there, And as we rotate counterclockwise, and then eventually we come to some sort of stopping point, some sort of stopping side. And where we end is called the terminal side. Okay, and so this right here, this is our angle of rotation. Okay. And it ends in our terminal side. Now, a couple of things here, just as a quick reminder. When we talk about this, sometimes we talk about quadrants. Quadrant 1 is where x and y are both positive, and then you go counterclockwise. So quadrant 1 is in the upper right, quadrant 2 is in the upper left, and you keep going counterclockwise 3 and 4. So those are our quadrants, and I should write that word out there. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. All right, now enough about some of those definitions. Let me undo to get back to just our grid. That might not be fast enough. Okay, let's just start over here with our grid. Eventually I'll get much faster at this for these videos, so you're not just sitting there watching me use a ruler. Okay, so here we are back at our grid, and we've got sort of the way things are named, and we're going to look at trying to find the measure of an angle as sort of it's stated. So I'm going to again take these examples for the angles and angle measure so we can kind of get a sense of what these things are. So the first one looks something like this. There's a terminal side that goes out in the fourth quadrant like this. Okay. It says that the angle rotates once around, ends there, and then it tells you that, hey, this angle right here is 80 degrees. And so this clearly this answer is going to be in degrees. We're going to be using degrees for this. And so basically all you do is you go, okay, well, this was 90 and 90 and 90. Or in other words, all the way to here is 270. And you just add that 80-degree angle in. And when you add that, you get a rotation of 350 degrees. So a rotation of 350 degrees is not quite all the way around, but it's getting close. All right, let me give you an example in radians. Let's see if I can undo far enough. There we go. Okay, so let me find the terminal side here. This looks to be example 14, which also ends in quadrant 4. This one rotates, it looks like it rotates counterclockwise all the way around once and then to here. And then they tell you that this angle in here is pi over 3. So that angle, this angle right there is pi over 3. All right, well, first thing we gotta do is, if we are going the wrong direction, this is not rotating counterclockwise, it's rotating clockwise. That means our angle is negative. Just like going to the right is positive, going to the left is negative. Going up on the y-axis is positive, going down is negative. So when it comes to rotation, rotating counterclockwise is positive, and rotating clockwise is negative. So this angle is going to be negative. So we at least have that. All right, so let's see here. We rotate one time around and then another little chunk. Okay, one time around and then another little chunk. And so as I look at this, first of all, this one time around is 2 pi. So I have negative 2 pi, and then I've got to go another negative angle because I'm still rotating in that direction. So I've got to go a little bit further, and if I go back and look at my unit circle, I'll notice that that pi over 3, sometimes it helps to think in degrees, just because you're more used to that. Pi over 3 is 60 degrees. So if this was 60 degrees, I would know that this is 30 degrees. And 30 degrees is equal to, is equal to pi over 6. Let me write a 6 there. Is 30 degrees. So I need to rotate another pi over 6. So I'm going to go one time around is 2 pi, and then another pi over 6. And this is where we got to go. Oh boy, got to remember all my fractions. Okay, here we go. So what I'm going to do is I'm going to take this negative 2 pi, and I'm going to change it into something that's over 6. So what divided by 6 is 2? That is 12. 12 pi over 6. So if you look at this, 12 pi divided by 6, well, that's 2 pi. So then minus pi over 6. So negative 12 pi's over 6 minus another pi over 6 gives me negative 13. Negative 13 pi over 6. And that's my angle of rotation in radians. That answer tells me the direction that I'm rotating clockwise because it's negative, and that I've gone actually more than one time around, that the rotation is further than that. This is actually, we're not going to get to it here, but it's actually really practical to talk about radians because now we have a direct way of knowing how far, say, you would move. If it was a wheel, all you would do is you'd take that radian angle and multiply it by the radius of whatever wheel, and that's how far that wheel went in that rotation. And it even tells you the direction that it went relative to your position. So there are some practical reasons for this, and you'll see more of that if you go in any sort of physics or anything like that. All right, okay, a few last tidbits of information. First, there are some problems that ask you to draw an angle with a given measure in standard position. So one example has negative 120 degrees. So I know I'm not rotating counterclockwise because negative, I'm going to rotate the other way. If I rotate this far, I'm at negative 90 degrees. So I need to go another 30 degrees, or roughly about here. And that's negative 120 degrees. So there we go. That'd be your drawing. This terminal side right here being in the third quadrant, about 30 degrees in. However, there's another piece of information I want to cover here just briefly, and that is something called the reference angle. The reference angle has to do with this. If you were to take that terminal side and create a right triangle where the right angle comes out of the x-axis, then the angle coming out of the origin, that angle is your reference angle. And if you were to think about this angle in terms of in a triangle setting, so in degrees here, or in radians, you can talk about in radians, this would be 60 degrees because this is 120 and the whole line is 180, so they must add up to 180. So this 60 degree angle, the reference angle would be 60 degrees. And this can be helpful to think about kind of the similarities between different rotational points based on that reference angle. All right, that covers angles and angle measure. There is a worksheet. You can also work through some of the assigned Khan Academy assignments when it comes to this as well. And feel free to ask questions. All right, see you soon. Bye.